Okay, so we had our normal Debian Help Check session, and we had some really great ideas. So it's my pleasure to introduce the newly minted Debian project leader, Stefano Zaccaroli. He just goes by Zach. So take it away.
So hey everybody, thank you for inviting me here. So in this very brief talk, I just want to present to you the feeling of the interaction among Debian and Ubuntu as it is perceived on our side. So what Debian thinks of the interaction with Ubuntu and what's good, what's not so good, and how we can improve it together. So let's start first with just a few characteristic points of the two projects, which highlight the differences among them. So about Debian, so Debian is one of the oldest distributions around. It's been around since 1993. And it's a purely volunteer-driven project, meaning that no one in the project is paid by Debian money to actually do the development. They do that just out of their enthusiasm. So the founding reason for having the project, which created the distribution, was a set of strong values, and in particular two priorities. So in the Debian project, we aim to basically push the free software everywhere as much as possible. And we have the priority of our users, with which we have like sealed a deal on a thing we call social contract, where we say our engagement with respect to the users. We are a quite big project. We have about 1,000 project members, which are kind of the official developers of the project around the world, plus other contributors everywhere. And the way we work is that we are basically duocratic, meaning that a developer working on some project area can decide what to do in that area. And when that does not work, like because other people think he's doing something wrong, we have democratic processes in which the developers together can actually do any kind of change, overriding any kind of decision by anyone, including the Debian project leader. So on the other side, as I see it, there's Ubuntu, and which is started in 2004 by Canonical. Originally, the technical team, as far as I know, was mostly composed by Debian developers, which were really happy to be paid to do what they like the most. And different from Debian, there are a couple of distinctions around, and basically you have a distinction, as far as I understand, between main and universe, and between the work which is done by the paid people, corporate people, and the work which is done by the community. While in Debian we have a more uniform situation where we work collaboratively on basically all the components of the distribution. The relationship among the two projects starts from the fact that Ubuntu is Debian-based, in the sense that periodically it forks Debian and it merges changes back. And that is the root of the collaboration among the two projects. So these are the numbers for Karmic, but I've been told they haven't changed much recently, which shows what does compose the Ubuntu distribution. So basically, about 75% of Ubuntu came from Debian unmodified, a bit less than 20% came from Debian modified, and about 7% came from upstream project not passing through Debian, and that includes stuff which is packaged differently in Ubuntu, and software which is packaged in Ubuntu but not in Debian. So the data, as you can imagine, includes both universe, and even if universe is not strictly speaking part of the distribution of Ubuntu, I think it makes sense to consider the data of both, because it's still one of the selling points. People want to do Ubuntu because they release frequently, but still they know they can get all the packages of Debian, so it's worth to consider the data together. Still, it is not all of that, so the collaboration among the two is really not only one way, but it's both ways. So there are some push. New microphone. So there are some pushes from Ubuntu to Debian, which are the key of the collaboration of the two teams. So these are the really good stuff about the Debian Ubuntu collaboration. So there are bug reports. There are some bug reports which each release are forwarded from Ubuntu to Debian. There are some changes which at each release are forwarded from Ubuntu to Debian, like patches attached to bug. There are some cases in which Ubuntu is a playground for testing big changes in Debian. For instance, the change of the default version of GCC, which is really useful for us. And most interestingly, there are really a lot of mixed teams in which you have both Ubuntu people and Debian people working together. So that's interesting for specific cases and also as a general trend, because as a general trend for us, it brings new developers to Debian. So there is a steady trend of people which starts working in Ubuntu and happen to work in a team which is mixed Ubuntu and Debian. And those kind of people in the end apply to become a Debian maintainer or a Debian developer. And that's really good for us. And there are also some specific really good cases like DI or DPKG, where there have been interesting cases of Ubuntu-specific features which have been generalized so that Debian can use them as well. But that benefits really all distribution based on DPKG or DI because they have a more general software to use now. So what should we learn from all these success stories is that we really like in Debian collaboration with Ubuntu. So they are really useful contribution for us that we really like. Still, we can do more, and before seeing how we can do more, I think it is worth to ask why we should be. I think there are interests for both parties. So the interest of Ubuntu in collaborating is that pushing your changes to Debian make your life easier. At the next cycle, when you're supposed to merge with Debian, you will have a smaller diff and then less amount of work to do. Another reason, which I think can be of interest for Ubuntu, is that in most cases, Debian maintainers are experts of the software they package. So they're not just people which know how to package, but usually they really know deeply the software they package. And that can be interesting on the Ubuntu side because it can improve some project areas like the universe, I've been told. So, and also, collaborating with Debian is the essence of the Be Collaborative mantra, which is in the code of conduct of Ubuntu. So, on the side of Debian, we have interest in the fact that Ubuntu has more users than what we have, so we can get more feedback from the software we package and we distribute, and in particular that can lead to have more developers, because you reach out a set of potential developers that we cannot reach. So that's really useful for us as well. And in general, we do care about cooperating with the distributions which are based on Debian to get better. Finally, there are some mutual interests which should be equally interesting for both peers. So there is a technical interest in discussing big changes together, because if you have a larger technical board with important technical insights, you will get better decisions from a technical point of view. And finally, we think we all agree on the fact that what matters the most is improving free software as a whole, and the more we collaborate, the more we'll achieve that. So, how can we achieve that? So now, it's a couple of remarks. I have the duty to be here and tell you what I don't like about the collaboration on Ubuntu and Debian, which is not really funny. So please understand it should be in both ways. So here, I'm to tell you what the Debian community does not like about the collaboration with Ubuntu, and I expect you to do the same with us, because it's only sharing this point that we can actually improve the collaboration. So, here's a couple of things. So, in general, there is a class of things that the Debian community does not like, and it is to deal with bad downstream. So what does it mean to be a bad downstream? So it means having bugs which are possibly interesting for your upstream, so in this case Debian, and which are not triaged or forwarded to your upstream. So in general, however, Debian developers are really interested in the bug which affects their packages after the sync with Ubuntu. So do not think that we don't care at all, because it is not the case. Still, there's a kind of community principle that we should not poll for bugs in all Debian derivatives, and that applies to Ubuntu too. So we really like to have bugs coming to us when we feel that Ubuntu is downstream for us. Note that this is no special casing for Ubuntu. We have the same kind of remarks with all our downstream, and I think it's a general expectation for people to have. So another one is those practices where we feel that Ubuntu is a bad upstream. That's more specifically to canonical, and I mentioned it here just because even though it's not necessarily interesting for the Ubuntu community, it's important to know why there can be tension among the two communities. So we have had some occasion in which the behavior has been not of a good upstream, and some examples are stuff which is hard to defriend, like there is a lot of useful stuff around the package management or services that Canonical offers, that can be useful for them as well, but is completely branded for Ubuntu. And it's kind of weird for us because we are used to have upstream. We generally care about the diffusion of the software at all. So really are interested in making it easier to debrand stuff, and that's not always the case with Canonical. And also the practices like when we feel that there is low interest in packaging in Debian Canonical software, or when we feel that Canonical is not responsible as an upstream, for instance, close to Ubuntu releases. But as you know, Ubuntu releases quite often, so the window of time of responsiveness can happen quite frequently. So this is what we feel from our side. We know that it's not entirely your fault, and we know that it's difficult sometimes, let's say sometimes, to interact with the Debian community. So here are some pitfalls that I think you should be aware of when interacting with the Debian community. So it might happen that you forward a patch to Debian and you just get ignored, okay? So that's not necessarily the fact that you get ignored because you come from Ubuntu. Maybe you just hit an abandoned package. We are a very big distribution. We have a long history, so we have a problem like missing in action package maintainer, this kind of stuff. You might have hit some of these corner cases. So maybe you're getting not just because the volunteer which is behind the package doesn't have time. So allow him to, a bit of delay, offer help, and maybe you will get a better answer. And you might get even a go to hell answer, okay? So in the past, the tension between the two projects were, I think, way worse than it is now. So, and still, you might hit some cases where you just forward a bug or something and you get ignored or flamed because you come from Ubuntu. Please remember that this is not representative of the whole interest of Debian in collaborating with Ubuntu. We are 1,000 developers and we have a lot of different opinions. Still, the general interest in collaborating with you is there, and please trust me on this. So, well, okay, right? You laugh, but actually, I asked the opinion of DDs on this before coming here, present this kind of stuff, and I was surprised myself by the fact that a lot of people is really interested in having changes from Ubuntu. So maybe there are not the vocal minority which flame on lists, but there are a silent majority of people which just don't tell that on lists, but it is interesting. So now, as I anticipate, it should go both ways. So I really welcome if you want to tell me, or in general the Debian community, what are the showstoppers of collaboration between Debian and Ubuntu, because only knowing them, we can improve the situation. So, to conclude, thank you. Thank you for having invited not only me, but Debian people at UDS. I think it's quite important to get in touch in person and discuss this kind of stuff. Thank to Canonical for sponsoring DebConf 10. It's really important for us, and it helps a lot of developers to travel and go there and act together. And we would like if Ubuntu developers or Canonical people would like to come to DebConf 10 this year, which will be in New York in the first week of August, to meet us, talk with us, and see how we can collaborate. So I welcome questions, and thank you. Run.
Earlier in the speech, you asked some of the things that we find difficult about Debian, collaborating with Debian. One of them that often comes up is an assumption that when something happens and the user reports a bug, anybody in Ubuntu notices. I'd say for probably 10 or 12,000 of the packages, there's 30 or 40 people who are looking at them when they can. Mostly volunteers that run into the same problem that the 1,000 Debian developers do.
Absolutely. I fully understand that. So what we would like is just knowing that you do effort in that direction. It is the impression that you don't, which is not necessarily true, but if it is there, there is either a problem that it's really not there or a communication problem.
Last one.
Just as a follow-up of this, I think we became much better in reporting bugs and patches directly to upstream instead of going through Debian and therefore hassling even more people about the problem. So maybe that also contributes to this view.
Well, but, I mean, bugs can affect the upstream software or can affect the Debian packaging. So I think it's just normal that if you have patches which are just upstream, it's okay to just forward them upstream. But what is not felt good is that you have a packaging patch which does not get to that.
I don't have a question, just to say thank you very much for coming and for your openness and for essentially your leadership around collaboration. It gives me a lot of confidence that we'll be able to do more if we have that kind of leadership. So thank you.
Okay, next up we're going to have Scott James Remnant, and he's going to talk about the plumbing. There's like 4 people in the world who know how all this works. Yeah, I think you're one of them.
And soon there's going to be 230 people that know how this works. Now there's confidence for you. This is only going to go wrong. Okay. Awesome. So, is everyone alright? Yep. Having a good time? It's got 1 day left to go. You don't have long. So, I'm going to talk a little bit about the plumbing layer. Normally, you guys are used to seeing me talk about boot. Boot's just one part of the plumbing layer. It's this whole sort of layer of Ubuntu that a few of us spend a very lot of time talking about. We have a conference about it each year, and everybody else is kind of mystified as to what it is and what it is. Now, one interesting thing about the plumbing layer is it's changed a lot. When we did WARTI, we had one type of layer here, and each release, everybody just got used to something. They knew a word, and that word went away because that piece of software in the stack got deprecated and removed. So we have a lot of ghosts in this layer. There's a lot of which I call sort of the ghosts. Some of those are the past ghosts, the ghost of plumbing past. Those, I did say I need a spooky change. Those are the ones that have long since gone, and no matter how hard you try and use them, they're not there anymore. There's the ghosts of plumbing present. They're the ones we removed in Karmic and Lucid. They're the things that you were really sure your software was developed for, and it mysteriously went away in Lucid when you weren't expecting it. Some of those you developed your software for and you got really excited for, and they never even appeared in any distribution. And then, of course, there's what I like to call the ghosts of plumbing future. That's the things you're using right now that won't be there next week. So, what is the plumbing layer? Now, this is a pretty typical view of what you might drop into. This is the kind of thing that sales guys will talk to people when they're explaining how an operating system works, and it's the kind of things that you put at the front of a book about operating system development. At the top, you have your applications. This is the things the users actually want to actually use on their computers. Things like Nautilus and Rhythmbox and OpenOffice and everything else that you actually want to use. Applications in the Linux system use the X server. That's the graphical server. You all know this. And right at the bottom, you have the kernel, the heart of the thing that does all the drivers and the thing that sort of connects, provides all the politics layer and everything else. So the plumbing layer sits in between the X server and the kernel. It's this sort of layer of services that you've probably heard of, but they're all these little layers of services. They don't have an X session. You can't get on the internet from them. But without them, you can't get on the internet. Without them, you can't have an X server. So things we include in Plummet, the init system, which is the boot stuff that you used to be working on, and UDEV, which is the other thing you used to be working on. That UDEV is the kernel's translator to user space. The kernel talks a lovely gibbery gobbledygook of everything that's happening, and UDEV tries to translate that into some kind of sense to be able to do things in user space. And other things like network manager and all sorts of other things sit in this what we call the plumbing layer. And that's kind of where it sits. So the plumbing word kind of got invented. I think it was probably Greg Hartman invented it, but I'm not entirely sure on that one. No one's actually come forward and claimed. We previously tried to call it the system layer, or the plumbing kind of joins everything together. It makes sense. It has actually several roles in the system. We provide service management to the rest of the system, keep everything running, your Bluetooth services running and everything else. Separation from the user from the system, and more importantly, separation from user applications from system services, and information about the hardware. And we'll look through each of these in turn as I go through the talk. And in particular, what's gone, what's new things. So, first one, something a little bit dear to my heart, service management. long, long ago in the history of time, or DAPA as it's more commonly known, we still used to use System 5 init. System 5 init is has been around since Unix. It actually, I'm pretty sure it's got to be in that list somewhere, but I actually couldn't see it in that little diagram of on the Unix book. I actually have that book at home. It's the service manager. It runs the services. It provides some basic functionality for dividing services, 4 customizable run levels that nobody uses, and 3 that nobody can touch because they're really important to shut down, reboot, simple things. Your start and stop scripts, start and stop services is all done by great big shell scripts which accumulate more and more and more little pieces that everybody hates. And there's really limited supervisor support. You can actually, nobody people realize that Sys5init can actually respawn services when they die. You just have to put them in etc init tab, which is really horrible, actually. All the init scripts and the RC stuff we're used to doesn't actually, you can't respawn those that way. So we sat down, I sat down, and we wrote Upstart. Now, Upstart is, so that Sys5init goes to present, Upstart is the present. Now, this is an event-based init system. This was very much along the idea that we have a whole waterfall of events coming out of the kernel. We know when things are plugged in, we know when hardware goes away, we know when disks are ready, we know when file system checks are complete, we know when buttons are pressed. These are all events. And we wanted to put an init system together that used this waterfall of events, and more particularly could inject sequences into these events in such a way that we can avoid all race conditions. If we know the events we need, and we hook on everything that we need, we avoid a race condition because we're just waiting in it for something to happen. We're not sitting in while loops, we're not sitting in sleep statements, we're not just running 2 things at once and hoping the red car beats the blue car. So it's, we're not, we wanted this to fix it. The job configuration, it's not shell scripts, it's a declarative, I call it. You don't, in init scripts you say how to run the service, in Upstart you say what service should be running. It's a slightly subtle thing, but it means Upstart does all the work of actually bringing up service, stopping the service, and so on. It makes it a lot easier in theory to write jobs. It has supervisor support, you can actually respawn Apache when it dies, and it was the first that I'm aware of one replacement in it that could actually supervise daemon processes that fork. It does it in a very, very, very evil way, but most importantly, it does it. There are going to be better ways. So, what is the future of service management? Oh God, Leonard's been fucking with my slides. So, the future is still going to be Upstart. Systemd is kind of cool, but it's LaunchD. We looked into that 4 years ago, and I'm still just as convinced today as I was then that while starting on socket activation is a nice thing to do, it's one tool you need in your arsenal to do to system, and one tool you need in your arsenal to manage a system. It's just one. We need a whole Swiss Army knife of tools. And we need, frankly, to support all the software that exists today. We don't want everybody rewriting their daemons. We don't need to. People running Apache have to do a FreeBSD and Solaris and Windows even. So, asking them to rewrite their daemon just for a Sys5init, an init replacement is not really on the cards. But that being said, Upstart's not perfect. I'm the first to admit that. That's why it's got a 0 point on the front of it, and it will still have a 0 point in the front of it in the future. But hopefully it will get better. The whole start on, stop on stuff that everybody hates, well, that was only ever intended to be temporary. I kept getting questions like, why isn't Upstart documented? Where's the guide in writing jobs? And I kept, there's no documentation. That was kind of deliberate. I didn't actually want people going and writing too many of these things. I especially didn't want them writing them without telling me they'd written one and letting me read it first. Because I knew the fact that start on, stop on was going away. The idea was always been to have an event-based init system, but not to expose every single one of those events to somebody writing a config file. The idea is instead that those internally managed states. So while Upstart might know the battery has been plugged in, the battery is at this percentage, it might know that a particular hardware has been inserted, a particular hardware being removed. To the job authors and the system administrator, it will expose them in forms of, we're in a hybrid, we're on AC power, we're on battery power, we're in a low memory situation, we are docked on a system. We'll expose them in these kind of high-level concepts, and that's what you're actually going to use in your config files in the future. Now, there's some nice things as well. Some features never made it into Upstart, in the early days. You can't disable services. Well, you will be able to. The fact you'll be able to do it in a nice way. You'll be able to mark the service in such a way that it's still there. You can still start it manually if you like, but it just doesn't come up on boot, and it doesn't come up when you insert the service. And there'll be some return of etc default override that I could have resisted initially. Some nice things like that. And we are going to do things like on-demand service activation. We are going to do things, particularly dbus service activation via Upstart, and we are going to do the things that we've always talked about, replacing cron, batch, and inetd, and so on. But this is very much a part of the arsenal. When you talk about just starting a service on demand, you don't really want to do that. I mean, cups is a good example here, and it's the one that a lot of people use, and I probably see Till jump in a second. Cups, you don't just want to start it on demand. You don't just want to start it when someone clicks the print button. You actually need to start it in case if there's a file in the printer queue. If you don't start it, if there's a file in the printer queue, after you might reboot, you might never print it. The printer might have been out of paper, it might have been off. But if you do that, and you wait to start it on demand after a reboot, well, that file in the print queue isn't going to actually get printed until someone prints something else, which seems somewhat personal. You need to start it to actually do service, printer discovery. You're on a system and this printer's over on another system. You actually need to start the cup server to do that, to discover that server and make it available to your applications in your local system. You don't want to wait until someone clicks print to at least discover the fact there are printers to print to. You want to, if you've got a printer you're sharing, you need to start cups to share that printer. You don't want to, the discovery is done by sort of lower level packets. But we want to do all of these things together. We want to start it on boot, but we want it to be started quite late in the boot. We probably want to start it after everything else. Once the desktop's loaded, it's quite low priority to get it started. If the print job you had when you shut down doesn't get printed until after you've logged in and started OpenOffice and started presenting on the sheet of paper, on the screen, then that's fine. That's not actually going to inconvenience users much. But if it doesn't start, it doesn't print, that's inconvenient. But if I start OpenOffice and I hit print now, if I want cups to immediately start, even though it's starting on idle. So we want to do combine all these things together to actually give us a decent state management and a decent service management. And the other thing we want to do is active state management. We want to be able to use Upstart to actively manage the state of the system. So just out of interest, who here plays videos on their laptop? Your hands up? Okay. Keep your hand up if you go around killing services some point during playing video because it goes a bit stuttery and you need the CPU, or there's quite a few of you. Well, wouldn't it be nice if the system could do that? If you're on an embedded system, we're building, let's say we do an Ubuntu tablet one day, let's say we do an Ubuntu phone and netbooks, we don't have the CPU power. Wouldn't it be nice if the services you weren't using shut down because you were playing video? We can turn them off, we don't need them right now. Wouldn't it be nice if you're running out of memory, and Upstart could actually shut down services using memory that it knows you're not using? And system load, wouldn't it be nice if you're using the system, you want to conserve power, so Upstart shut down services known to consume power that you're not using? Again, they'll be on-demand started if you want to use them, but having active system management is something else we want to do there. So, that's the future of service management. Continuing on the track we've gone on, continuing to develop Upstart, and we're now, I'm sure most people have noticed that Upstart 0.6 was in RHEL 6, so it's going to be in RHEL 6, and in OpenSUSE 11.3, which is their next version, I think. And I'm really hoping that Debian will sort of take a decision and use Upstart as their daemon. So we're sort of the major Linux distributions are now using it, and they'll be able to use these new versions as well when they come out. So it's sort of a big thing that we've been working on. Now, user and system separation. Anyone remember pmount? I kind of actually, I'm not sure I got the architecture quite right here, but it was sufficed as an example. Now, in the old days, the way user applications used to actually get to system hardware was they ran setuid. They ran as root. Well, they ran as root or they ran setuid. So the application would be running as the user, but it would run something that actually ran as root magically through the magic setuid and would do work as a privileged user. And it was a really, really bad those are the services, those are the systems and the programs that keep case up at night. The worst ones are the ones that actually ran X applications as root. Those ones don't just keep case up all night. Those ones keep case up all night crying. And there are others, we use special magic groups, like you had to add yourself to the audio group to be able to use the sound card. And, well, if I'm confronted with a dialog box saying, here are the list of things that you can do with your computer, and some of them aren't ticked, I say, I'm going to go tick all of them. I want to do everything with my computer. And we've pretty much found that users tended to do the same thing, which defeated the entire object. In fact, I actually was I wanted to have like 3 examples of the things here, and believe it or not, there weren't many examples that you booted Warty to figure out what, figure out how it did. And there weren't many examples. The actual simple truth is, it was so hard for desktop applications to access hardware, we didn't do it. There was no network manager. There was no VPN tool. There was no sound card properties, mix the settings. It was all, there was the basic ones that we had, but most of them were missing from the desktop. You plugged a USB key in, it just about worked. You plugged a scanner in, no chance. We simply didn't have all these features. The plumbing layer gives us these features. Now, here's sort of a better model of how things are today. We have applications for the users sit in the session. Now, the plumbing layer provides system services. These are actual examples from Lucid. We have UDS, Network Manager, and UPower. Now, the services are connected. These services run in privileged state. They might be root, or they might be privileged with capabilities that your user doesn't have. Your user has no privilege or capability. The services connect via the dbus system bus. Now, this is a bus, an IPC bus. It's basically a way of sending messages. It's a bit like kind of Corba or anything. DCOP was the old KD one dbus is actually based on. And it provides the ability to talk to these services and for services to talk to each other. Now, the applications that want to talk to these services therefore have permission to talk to these services over the bus. And a common point of confusion, these applications talk to the system bus. They connect to the system bus. If Nautilus wants to talk to UDisks, which manages the disk subsystem, it connects to the system bus to talk to UDisks. When GNOME Power Manager wants to talk to UPower, it connects to the system bus to talk to UPower. There is another bus, the session bus, that is not related. The session bus is actually used to only communicate between applications. The session bus is used so your screensaver can pause Rhythmbox, or no, it's the other way around, isn't it? But the screensaver is used for things in your applications to talk to each other. It's used for inhibiting the screensaver. It's used for remote control of Rhythmbox. It's all those kind of things. The session bus and system buses are not connected to each other. They're not related. If you want to talk as a user to the system, you talk over the system bus to a system service, and the system service provides you methods to actually access hardware on your behalf, and provides you, there are privilege layers in there. There's a system called Policy Kit, which allows you to obtain authorizations to actually talk to these, allows you to obtain authorizations to bring up a network card, and so on. And most of these are on for the default console user. Now, so this is the present. We have these 2 layers. Now, actually, it's not quite true. The system services are managed by Upstart here, pretty much. The session applications are kind of session managed by the GNOME Session Manager. You click on them in the panel more than on Docky or whatever. But if you left them open and session management worked this week, then their session would be their state would be saved in the session. If you log back in again, the app would appear in the same place at the same time. This worked in the 1970s, it hasn't worked since, but it will work again one day, I'm sure. However, there's also a bunch of other pieces sitting in this layer. So let me actually press the clicker. So there we have the future layer. Now, inside this session layer, there's a bunch of services. Right now, some of these services are really per user. They're not per session. If you log in twice on 2 different seats, you still only need 1 copy of this service. You still only need 1 of these services running. So the future here is to use Upstart, I really said leverage, is to use Upstart to manage these services. We can use Upstart to manage SSH agent. We can use Upstart to manage DVFSD, Pulse Audio, those kind of things. You only need 1 of them if you're logged in. It's kind of cool, there's a kind of cool features. Most of this is nice, geeky, we simplify the system, these services will respawn if they crash, and all those kind of nice things that we get from having a service manager look after them, but they're running as the user. The other nice thing that you can do is you can get little cool features. You can sell this, like, You start X, you have your SSH keys, you add them, and then you switch to BT1 and you log in on the text console. You still get your SSH keys there. It's still using the same SSH agent. So little niceties like that make it simpler for everybody. And there are actually some, I haven't put them in this diagram, but there are some services still running in the session. We were trying to think of the screensaver as one of them. The difference between the session and the user here, the session would go if you logged out, and the session has access to your X server. User services don't go until you log out the last seat, and user services don't have access to the X server. So there are things like screensaver stuff in the session layer. Now, we will also manage those with Upstart. And the debug session bus. Always forget about that one. The way we'll do this is that when you log in, Upstart will create a new session, start some services like the debug session bus and screensaver, and then we'll just start the same old GNOME session that you're used to. I'm going to be very clear on this. Upstart is not going to replace the X session manager. X session management.
User scope debus?
Sorry, question there was about user scope debus. We can do user scope debus. So user scope debus is this idea that you have one debus server, so one debus session bus for your actual whole user, or another debus, you have a debus session bus, debus user bus, debus thing. Easy. This model makes that really easy to do. If you want. Will I if you want? If someone wants it, I will. If someone comes up with a use case, I will. I've got no reason not to do it. But I don't have a reason to do that either. Okay, there you go. So yes. I will. Now, we're not, so anyway, so we're not going to replace X session management. I do not want to Upstart to care about where your X windows were. I do not want Upstart to care about how many X terms you had open, terminals, or any of that stuff. You still need a session management manager. You still need something to the X session management protocol. You still need something to restore application state when you log in. You still need, all of that stuff still stays. We're just services that are running move into Upstart. Okay. So, the last point, last set of points here. Hardware information. Now, this is kind of one of those areas that changed a lot. Now, what used to happen, this is kind of Warty era, or Hardy era, the kernel used to actually execute sbin hotlog every time a device was inserted or something changed. In fact, it wasn't. It pretty much did it only when a small subset of things changed about the system. But it literally forked and executed the shell script by itself. This suddenly appeared out of nowhere, out of the kernel, and ran. It was a horrible shell script. And one of the things, I've massively simplified this, don't I? If you know actually how all this works, I'm worrying that it's wrong. One of the things that hotplug would cause is the HAL, the hardware abstraction layer daemon, to receive updated information about the hardware that had just been inserted, usually network device, and update its database of what hardware was connected. Now, HAL would provide the information about those hardware over the system bus to your applications and your X server and your services. And it would also provide some methods to actually change that hardware, mount disks, things like that. Now, over the years, this changed a lot. Hotplug went away and was replaced by UDEV. Now, so if you've ever seen Hotplug around, if someone's still trying to give you a file that goes into Hotplug, they're really, really, really out of date. That hasn't been true for a very, very long time. Actually, the kernel stopped executing things as well. We actually got a proper socket protocol from the kernel. If you want to receive information about hardware events, you connect to the kernel and it gives you this fire hose of events in what we call U events. No one's ever known what the U stands for. It's just, there's a U everywhere. Not micro or small. Some of them are quite large. Anyway, U-event netlink socket gave us the ability to receive a torrent of events from the kernel itself about what was happening. And UDEV actually eventually learned to feed back into that netlink socket after it had finished its work that it was doing to update the rest of the system. And then services like HAL would receive the events of netlink. I'm trying to kind of simplify this, so if you know this is a good lie to everybody who doesn't know how the system works. Now, UDEV got increasingly complicated. It had to actually remove the device nodes again after they were added. It had to remove all the symlinks attached to those device nodes. It had to start probing devices. It had to create symlinks. It had to run scripts. It had to remember to run scripts when the device was removed, but that it needed to know all about the device, but the device was removed, so it couldn't probe it anymore. So it got really, really complicated. So someone stuck a database on the side of it. Big text file. This is kind of looking a little bit duplicated, wasn't it? So fortunately, everybody suddenly realized we had two things doing exactly the same job, and we got rid of HAL. Now, if you're running Lucid, you don't have HAL installed by default. Some services still use it because they use its methods, but it's activated on the system bus when those services try and use it. We actually do not have it running by default. Martin, is it actually on the CD by default for Ubuntu?
Yeah,
it is.
Brightness management.
For brightness. All right. So it's still on the CD by default for some graphics cards which can't do brightness management by themselves. It's not, that's right. Yeah. Now, HAL was replaced by UDEF. HAL was replaced by the thing that was already there alongside it. The new way was, rather than connecting over dbus to talk to HAL about the device information, you just connect to the kernel's UEvent netlink socket or the UDEF echo of it, and you just look in /sys for the hardware information, and if you need more, you ask UDEF via the libudev thing to access the DB yourself and actually connect the dots. Now, we added the notion of subsystem daemons. These are daemons responsible for their particular type of hardware. UDisks is responsible for disks. It takes the kernel netlink socket, provides dbus objects for those disks, provides methods on those. If you want to mount a disk, format a disk, create a RAID or anything, you can use UDisks to do that. I believe USB Create uses UDisks and so on. UPower replaced the parts of HAL that did power management. So again, that UPower listens to the kernel netlink socket, creates dbus objects for power state on the system, exports them over dbus, and provides methods to change the state of power. You can change the brightness and echoes out things saying the system's been idled. You can have something in the user session change the brightness, and so on. So these replace the parts of HAL. Now, quite a common question, where's U input? Where's the thing that does keyboard? Well, it's X. If we didn't put a subsystem daemon in, if there wasn't something that actually was already doing that job just fine. The subsystem daemons only exist whether we wasn't anything else. X already handles input, so X listens on the UEvent netlink socket, creates input devices, makes them available to your applications. U audio, well that's pulse audio. And network manager, well that was U network or whatever. Yeah. Some of the daemons became subsystem daemons, even though they even predated the invention of subsystem daemons. However, others didn't. Now, you've probably heard of something called device kit. Yeah, that didn't go anywhere. Device kit, the idea was to have a daemon that just sat on the UEvent netlink socket, exported everything over dbus, and then UDISK, UPower, network manager, everything else would connect over dbus. And again, so we're having netlink, so we do the UEvent netlink to dbus, it just creates more work for everybody. So, 3 minutes. Okay, I've got about 3 slides left. Pretty good at this, aren't I? So, we're done, right? This is the future. X will run as a user, but other than that, we're in the future. Well, what's this bit do? Why do we have this daemon sitting here reading all the event from UEvent netlink when everything else can read from UEvent netlink? Can we just do that? Well, UDEV creates the device nodes in /dev. No. The kernel creates the device nodes in /dev. Dev-tumpfs replaces that part of UDEV. Dev-tumpfs is create the device nodes made by the kernel, removed by the kernel. This is enabled in Lucid, and it's on by default in Lucid, and will be on by default in all future parts of the system. Well, UDEV sets all the permissions and the groups of those device nodes, and creates the symlinks to those device nodes. Well, not really. We actually use ACLs mostly. If I'm to access the audio device, we add an ACL for me to access the audio device. We don't put me in group audio and so on. And the audio group is just there for daemons that need to access the audio device. And these are added by an external helper that's run by UDEV on those devices and when someone logs in. So, well, that helper could just chmod and chgroup as it goes along. Well, the other bit UDEV does is it lets you rename devices. No, it doesn't. The most recent version of UDEV deprecated you being able to rename devices. You can only add symlinks to them. So this external helper could actually just take over the job of the permissions and groups that UDEV does. But UDEV does all that cold plugging stuff on boot, and it proves every device on boot, and we actually look at every block device. Well, the 90s called them, who the hell probed every single device on boot? Why are we actually probing everything? Why do we go, there's a disk array there, probe? Why do we do this? If nobody cares, why do we probe? If the subsystem daemons took over responsibility for probing, if UDisks, which happens to probe already, by the way, took over responsibility for probing disks, UDisks is service activated. UDisk is not running unless something cares about disks. So you don't probe disks unless someone cares, and you probe them when someone cares. You don't probe power devices unless someone cares. You don't probe input devices unless someone cares. So we do a lot less cold plugging and probing at boot. Well, that's a really good win. And well, all the device information there is sitting in /sys. You know, UDEV came from a time when we didn't really have /sys. It predates it. But we have /sys now. We have the tree of devices. We don't need to talk to UDEV to find those devices. We've got a file system we use. We'll keep libudev. Libudev is a cool tool for actually talking to the event network socket. And libudev lets us iterate /sys easily. And libudev lets us read the UDEV DB of the extra information we've gathered from the probing. But we don't need the daemon. But now, yeah, it does post insertion run rules. You know, after you put in a device, it runs something. You know, that's really important. You know, and that's how we run mobprobe. Well, Upstart actually listens to the event network socket. Upstart, you know, we have those horrible actions add subsystem is Bluetooth run plus equals user SB. Or we could just write it in Upstart. Well, Bluetooth run the Bluetooth daemon. You know, when a device is added, mobprobe. Upstart's easier to write. If we've got Upstart wrong, they're harder to write. But Upstart can do the run rules. So what is UDEV doing? So that's the future of the plumbing layer. Well, UDEV's probably going to go away. Oh, yeah, one other thing. You know, I mentioned about Upstart running user and system services. If Upstart's doing the, I really didn't pause the one more thing. Good love. If Upstart's doing the network socket, which it is, and if Upstart's letting you run things, you can run them as a user. You can run them inside the next session. You can write a task which is run inside direct session as your user when a device is inserted, and you can pop GUIs up and everything. So this is better. Thank you.